Hello, my friends. Welcome back. We are working on enhancing the card game war project from the WiByte Python curriculum available at www.wibyte.in. In the previous video, we saw some interesting ways to deal cards. Now, in this video, we will enhance that further. We'll go further in that. We will deal using random numbers because whatever we have seen so far are very structured, very nicely patterned, ways of dealing, which are all nice. But we can add randomness to this. For example, the only thing we really have to worry about is that both players get 26 cards, say in the 52 card deck, or 27 cards in the 54 card deck, and these cards are unique. They are, non-overlapping. Now, we will see three methods of how we can add randomness to this. Now, technically speaking or strictly speaking, this does not change the outcome of the game, but still it's very interesting because these ideas could be useful somewhere else. So that's what I thought it will be interesting to incorporate this. The first method just The first method that we look at just follows from the loop that we have been doing earlier. Remember, previously we were slicing the individual chunks. First half went to the player, second half went to the computer, and so on. And we could change this depending on the number of cards we want to deal and so on. Now we can make this random, and we can say that look, at every pass of the loop, I'm going to toss a coin. The first part may go to the player, or it may also go to the computer. In which case, the second part player. So what I will do is that I'll say, okay, look, let me first create these two lists. Now these slicings are exactly what I was doing earlier. Now I toss a coin and I say, look, if coin is 0, then my player gets part 1, computer gets part 2, otherwise reverse. So we can first see this working. Previously I was doing this and I've gone back to my cards being, let's say, 0 to 52. And you notice here I'm doing slicing with, I'm doing, let's say, dealing with, two cards dealt per player. So that's why I'm seeing 0, 1 to the player, 4, 5, 8, 9, and so on to the player, 2, 3, 6, 7 until so on to 51 for the computer. Now let's say I just sort of extend this. I say, look, list 1 is given by exactly this list over here. And list 2 is another list which is given by, let's say, this list over here. Now these slicings we have already taken care. They happen, on every pass of the loop. So I will just say, all right, list 2 is this. Now, if I were to just do, let's say, extend list 1 and let's say computer cards extend, say, list 2. Now this will keep the game completely unchanged. We can actually see this working so that we are sure everything is all right. Notice when I do this, nothing changes. I get the exact same order 0, 1, 2, 3. 0, 1, 4, 5, and so on for the player, 2, 3, 6, 7, and so on for the computer. However, what I want to do now is that I'm going to say, look, I'm going to toss a coin here. So I say, so coin is, let's say, is equal to, let's say, random dot, say, rand int. And, I say, let's say, it takes two values. And now I make a decision. Well, if coin, let's say coin is equal to, say, 0, in that case we stick with the original, let's say, allocation. Else I reverse these two. I say, well, player cards can be, let's say, list 2. It can be extended by list 2, and computer cards can be extended by, let's say, list 1. Now this is going to create some randomness, and you can see this one. So now when I run this piece of code, now when I run this piece of code, you can see that the code has taken effect. So I got 0, 1 for the player, 2, 3 for the computer, that's like earlier, 4, 5 for the player, again same as earlier. But notice here I got 8, 9 for the computer. So it's kind of diverged over there because now it depends on this coin, this variable called coin, which is really like a coin. 50% of chances does this, 50% chances does something like that. Now, like I said, these ideas could be quite useful elsewhere as well. That's why I'm doing this here. Now, a very important point to understand here is that when I'm dealing these cards, the loop is already set up in a way that I'm ensured that both players will get 26 cards, or say half the deck of the cards. That's because the slicing has been set up that way. We spoke about this already in the previous video. But we can look at a different method where we have to do a little bit more work. Let's say I say, okay, instead of being very structured about it, say, okay, I'll give 3 cards to you, then 3 cards to you, 3 cards to you, and so on and so forth. Let me give you both the players a random number of cards. So for example, I can say I'm going to give you a random number of cards between 1 and 3. So let's say the first player gets 1, the next player gets 2. After 2 rounds, first player is 3, next round is 4. I keep on doing this until one of the two players reaches, let's say, close to 26, 26 being my halfway mark. And let's say now I have to give 3 cards. So, well, clearly I can't give this guy 3 cards anymore. So what I'll say is that, okay, look, I'm going to give you 2 cards. That will take you to 26, and all the remaining cards should go to the other pile. Now I'm going to make this check on both of these. Any of these reaching the limit of 26, I will stop this. Now this is very interesting. In fact, when we games, we do this kind of tricks without thinking about them. So I randomly keep giving, let's say, 1 card, 2 cards, and so long as you're counting how many cards you have, this is going to work. But writing this code is a little bit more involved. Basically, I'm going to keep track of a variable called running count. This should be run count. And basically, I'm going to pick up 2 random numbers for, let's say, the computer and the player. Like I said, I'm going to check if one of these is going to exceed the limit. So if that is going to happen, well, I limit the number of cards that I'm going to add, and I exit from the loop. Once I do this, well, I just allocate the appropriate number of cards to the player, and let's say to the computer. Right now, here I'm using a for loop. That's why I'm using an append, because 1 card is being added at a time. And of course, I must keep track of this running count, which is telling me how many cards have been used. Now, this code little bit involved, but it's fun to sort of make it happen, make it work. It's good to look at it working. So what I'm going to do, I'm going to come in here, and I'm going to say, look, I don't want any of this. Here, I'm just going to say, we don't need this structure anymore. Maybe I can just do a new one here, right? So let's say my deck of cards is, so once again, I come in here, I just say, well, deck of, say, cards is, let's say, n for n in range, say, 52. So that's your new deck of cards. It's kind of starting afresh. So here I go and say, well, CNT is, say, 0. So there's a run counter. We'll see the meaning of this. I'll say, well, done equals to false, false, and I say while not, say, done. And basically, once when I'm filling up when I'm dealing the cards, I just pick up, let's say, 2 cards. So I just say, let's say, n cards, say, p equals to random dot, say, rand int, say 0 to, say 1 to 3, and same thing for the computer. So I just pick up, let's say, an equal number of cards for the computer. Now remember, I need to check in case I am exceeding this. Now how do I know if I'm exceeding this? Well, actually, before doing anything, I must set player cards to an empty list, and likewise I must set compute cards also to an empty list, right? So now once I have picked up these cards, I will check if adding this many cards to my existing computer or player cards, will it exceed, let's say, 26, 26 being the halfway mark. So I'm going to say, well, look, if len of, say, player cards plus, say, n cards p is greater than 26, which means I'm already close to the limit, and I picked up a number that will push me beyond 26. I obviously do not want this to happen, so I'm going to limit my n cards p to just 26 minus, say, length of player cards, and the remaining, all the cards should just go to the computer. So I'm just going to overwrite this n card c as well, and I say n card c is given by, well, nothing but 26 minus length of, say, compute cards, right? So basically the loop is getting over, and I said done is equal to, say, true. Now, on the other hand, let's say I, do not have a problem on the player card, but I do have a problem on the computer card. So I do the exact same thing for the computer cards. I just go and say, look, here, if let's say my computer cards are sort of too much, so compute cards plus n cards c, if this is becoming more than 26, then I'm going to say, well, let me limit my n cards c to, let's say, length of 26 minus length of compute cards, and of course my n cards p will then be all the other cards, and that has to be also 26 minus length of, let's say, player cards. Now it's important to understand why we are doing by the way, I have to do turn equals to 2 over here. It's important to understand why we are doing an if elif statement here. Why not 2 if statements here? The reason is that, I'm checking for either the player or the computer. If either of them breaches, that's good enough for me to say, okay, the loop is getting over. If I did this sequentially, then I may end up checking for both, and that causes a bug. In fact, that's what I did before I realized that mistake and fixed it here. So it has to be an if and elif. Now, having done, how many cards I need to give to both the players, well, I just need to now allocate those cards actually into the list. So I could have done slicing here, but I will just go with the, let's say, the for method. So I'll say for, let's say, kk in range. Now this range is very interesting. I'm going to run it from run count. Now this is a running counter of how many cards have been dealt. I start with 0. Every time I deal some cards, I increase my running counter. This is like a kind of like a pointer. So I say running card, say run card, run. So to run, say cnt plus n cards, say p in steps of 1. Now this is, remember, start stop step, again exactly same as slicing, but this is using range. And what do I do with this? Well, I just say player cards dot say append, let's say player cards, so deck of cards and kk, because basically those elements I need to append. Now since I've added n cards p over here to the to the deck of cards, to the, sorry, the player cards, I'm going to move my running counter to, let's say, running counter plus, let's say, n cards, say p. Now I'm going to do the exact same thing for the player card. So first I deal to the players, to the computer cards. In this case, I'm first dealing to the player, next to the computer, but exactly the same thing. I say, well, let me get the next n card c cards for the computer. So here it should be compute, compute cards, and append exactly the same way. Now, of course, my running card should be increased by, say, n card c. Now this is actually quite interesting, maybe a little bit confusing, but we can actually see how this thing goes by just saying print, let's say, run cnt. So we'll get an idea of how the lists are forming, and at the end of this we can look at our as before, we can say print, let's say, the length of two lists and as well as the two list itself. So I'm just going to say these two, and including their length. So I can just print, let's say, say len of, say, player cards and say player cards itself. And finally I'll say, well, len of, let's say, compute cards and compute cards. So when I run this now, notice my running counter went 0, 3, 7. That's because I'm adding that many cards. So just I'm keep on randomly adding cards to the two lists, but eventually I reach a point where I just add the remaining cards because I think one of them was reaching faster. We could have plotted the this is cards P and card C, but you see that eventually both of them have 26 cards, and that's what I wanted. And I have done it fairly randomly. This is a working method. That's why, yeah, quite interesting. Now this may have looked like a lot of work. Definitely it is, but I added this because the thought process is quite interesting, especially the way this while loop works. Happy to discuss. However, a simpler method exists by using the random.sample method. Now, random.sample method is a pretty interesting method which gives us a lot of cards from, let's say, a lot of items from a list. The important bit is that these items are all totally unique, and this is what I want. This is, we do not want cards to be repeated. So I just say, okay, player cards is random.sample deck of cards, say 26. So I pick up 26 cards from the player cards. Now I go and remove all those items that have been picked up for the player card so that the computer doesn't get those cards. Now at this point, in fact, the deck of cards has only 26 cards, but again, I use random.sample here. So if I go and do this, let's say once again, my player card and computer cards, let's just say this is actually the simplest method in a way. So I say, well, player cards, let's say I first set it to empty, compute cards also, let's say I set this list to empty, and I say, look, player cards is equal to random dot sample, let's say, deck of cards 26, because I want 26 cards to be given to the player. Now remember, once I've given a card to the player, I do not want these cards to be given to the computer. So I just go and delete these from the deck of cards. So I say for, well, AA doesn't really matter. I in say player cards. Well, I want you to remove, say, deck of cards dot remove, for example, AA. Now, here we are using item removal of an item from a list by explicitly naming that item, not using item number and so on. So here I just remove those items. And once having done this, I can say, well, compute cards is equal to random dot sample, for example, deck of cards 26. Now, really, there are only 26 items on there. So it is basically bound to give us, let's say, a new list. So when I, let's say, do this now, once again, we will run this to see, what's going on here. So notice my first time round, I had a, well, I was doing a little bit, let's say, randomness in this. So I got 2, 3, 0, 1 went here. Next, I got a completely random two lists, right? 26 and 26. Now, again, I've got completely random lists, but these are all jumbled up because first I picked up 26 cards from, the deck of cards. Next, I picked up new 26 cards. These are non-overlapping, which is fine. But here, this is also a valid method. These look jumbled up, but they are actually quite correct, right? Now, before I wrap up, I do want to make a point here. Random.sample versus, let's say, random.choices. Now, what's the difference? Previously, we used random choices when we were picking up two cards. In fact, I later realized that this is not entirely correct because this can give me repeated values. So if I do random choices, if I run this many, many times, I will end up with repeated values. The right thing to do is random.sample. So which means that over here as well, we should use random.sample. The beauty of random.sample is that it's going to give me 26 cards in this case, which are all completely unique. That's what I wanted for the toss as well. So the difference between choices and samples is that choices will give me those values, say 10, 20, whatever number of values, but they may be repeated. With sample, I'm guaranteed that there is no repeat at all. I hope you found this interesting. These small little ideas, these small little concepts are very, very important the way you program. And it just helps to know these details. In general, if you think this way of learning where we build activities, where we enhance them, we think through ideas is something that appeals to you, look at our website because that's how we learn Python programming. Take care. Thank you so much. Bye-bye.